Why it's still for now? Is it working now? I don't know. I hope. I think it's working now, right? But how? Why my YouTube didn't show up any? Maybe I should. How do I know if it's on? Okay, so now it's on, right? Now it's on. Maybe I should. Oh, good. No, 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 no. All right. All right. So today let's keep solve another five more leetcode questions. So we are solving the leetcode 150 from here. So right now today we are going to solve from um the the main stack and evaluate reverse Polish notation, generate parentheses, parenthesis, parenthesis. I cannot spell. And daily temperature and the car fleet. So five medium questions and it's all stack. Maybe I should do this in this order. All right. So the first is the main stack, and this question I think we can use the Python building list for this question. So so this asks you to have a stack object that you can push, you can pop, and you can peep, which gets the first element of the stack, and also there's a get minimum. You have to get the minimum element in the stack. So and the tricky part is you have to do this in all of one time. So in order to get the minimum, if you cannot just traverse the list and find minimum. So we actually need to have another stack. So that is storage, the current the minimum. Which whenever we have a minimum, we push it to the minimum stack. So when we call the get min, it just get the the very last one, which is from the stack, and we can get the minimum. So so yeah, so as long as we know this and this question is easy, so we can do this stack self dot stack is equals to a empty string, and also we can have a main stack. I don't know. They say Python to ask you to do this style, but either way, it's fine. So for the push, it's easy. We just need to self dot stack dot append value, right? And also we need to push a value that is to the main stack. So what we are trying to do is we compare the value. So first of all, we have to check if main stack is is available, and of course it will be available because it's like it's already been initialized, so it will be available. Um, but since we need to check, make sure the value if it's like the minimum value, so um, so we can just uh, we can append the, the the minimum because we want to get the minimum of the value, or if there's no value in the main stack, we're going just to append the main value anyways. So we can get um, so we have to come to see if we have like what's the minimum of the stack right now. If this available, else we just return the value. So we do need to check because there will be chances is our like this -1 doesn't exist. So let's make sure we got there's a value in the list, so we can return the last one of main stack, or yeah, or we can use like non-empty or something, But I think this should work. And to pop, we also have to self dot stack dot pop and self dot main stack. Um, we also have to check if since we're using the stack, so the minimum value will be always on top of it. So we can also pop. I think we need to check if it's so. Right. So they say if we have a list of maybe like 132 something like this, right? And so the stack would looks like 132, right? And the main stack would look like 1 1 1. Okay, so since um, since we are going, if we pop like this one, we pop this one, and this one is still the minimum of the whole list for all the state. So we just pop it, right? So yeah, uh, that's I think that's why it's better to visualize it before you code. Otherwise, my brain will get stuck. And for the top, we just return self stack um like minus 1, and And to the get main, we just return self dot min stack -1 as well. So I think that's okay. Okay. Did I did wrong? Did I do anything crazy? I don't think so. Oh, I think it should be this one, right? The indent. No? Oh, how is this possible? How? So if I do this, what? Seriously? Where did I do wrong? Let's start it over. Alright. Self dot stack. Self dot main stack. Alright. Um, for the push, we just self dot stack dot append self dot stack main stack append. It's the minimum of the value or um, the main stack self dot main stack um, -1 if self dot main stack is real, else value. Okay, self dot stack append, not append, dot pop. I think maybe in the previous version I didn't add the self, so maybe there's some pointer issue there. All right. something like this, right? All right, I guess, yeah, I must missed some, so where am I? Huh, not sure where did I did wrong. Okay, I guess here, right? So, anyways, all right. So this is the first question. And the second one is the evaluate the reverse Polish notation. So um, this question it gives you tokens. So it's a string, and you will have to it will always calculate the first two elements. So like if we have the if we saw a symbol, then we would go to the previous two character and we calculate them first. Then we will continue our operation. So it's 2, 1 plus. Then we add 1 plus 2 first is to 3. And now it's like 3 times. So we 3 times this is equals to 3. So to 9. So so also there's also a tricky part for this question is the division has to turn k to a zero. So in Python, if you just use the divide um, operation, if it's like negative, it will um, round down to negative infinity, round down to the floor. So so we might need a special trick that is to make it float, then we make it integer. We use float to perform the division, so that will give us the flow number. Then we turn that flow number, negative flow number, into integer, so it will goes toward zero. So so yeah, so and the key thing here is we should use a stack, and we should just iterate through the list. And so if it's not like plus, minus, star, as in division, then we would check and we would append to our stack. So things it looks like this because they are the string. You have to turn it into integer, and if it's not, means we have encountered the special character. Then we would take two numbers from the stack, and we will perform the operation there. So we would pop, and we pop it again. So that way we took the first two and numbers from the stack, and we would perform the calculation there. So if C is equals to plus sign, then um, we just return. Oh, we don't return. We have to keep appending to the stack. So in in the end, the stack will be shrinked to just one element, and that's our answer. So So the stack dot append b plus a, else if c equals to minus stack dot append b minus a. Right. Um, else a, and else use slash means um, load b divided by a, and we can do the integer, so it's always it's turn cat to 0, and after all this um, we just return stack minus 1. So I think this question is the tricky part is yeah, it's this one. You have to turn k towards 0. So integer float division, and then the integer will gives you the division turn k towards 0. So okay. All right. Next, generate parentheses. So it gives you um, uh, n, and you should return all the possible combination of the valid parentheses. So so this question is more like a DFS tree. So we keep adding the left parentheses uh, until it's open. So we will have a number of open parentheses, and also we will have a number of close parentheses. So um, so we would so which each node we would have, like, can we add open parentheses, or we can add a close parentheses, as long as the open parentheses number is larger than the close parentheses. We can choose either one, right? So we just keep adding left, right, left. We just keep adding left, and we add right. So when would we reach the leaf is when the number of close node equal number of number the node, when do we know when we reach the result is like the open parentheses number equals to the close parentheses number and equals to n. That's when we know we have the valid parentheses. So 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 for example, this has 3 open parentheses and 3 close parentheses. Then it's a no, it's a leaf. And also this one we add 2 open, and then we add 1 close, it's still valid. And then we have 1 open, so now we have 3 opens, and 2 close, 3 close, so now it's complete. So so yeah, so let's write the code. So we would have open and close, so set to 0, and so we would write a recursive code, maybe called DFS, and we just take the open end and close end and the path. So we also have to initialize a string. Um, so okay, so while um, open n is greater than the close n, and and so we have to write our base case. When do we stop, right? So if n equals to okay, so if n equals to open n and close n in this case, I'm not sure Python has this. Um, anyways, I bet there might be some cases. Then we return, right? Um, so if it is, we just keep coding this, right? Um, plus one goes in, and we add to the string. So um, path plus um, this one, right? Um, okay, and also while the close end is I think should be like this, right? And in this function, we just code starting from the 0, 0, and s. We just return this. Did I miss something? Not sure. think, yeah, it's still on. I think so. Maybe we should code this path and just return path. Mm, okay, that did anything wrong? Oh, okay. Yeah, I think we need to. Yep, that's why I'm thinking how do I to storage all um the thing. So so we should append in here, right? And we just return results. Okay, wrong. Did I what did I did wrong? Uh I think this one because they have to all strictly equals. So so it's like no. Oh, where did I do wrong? Oh, it's if because we are calling it recursively. So if it's like while loop, it's still wrong. How? Um, so what did I do wrong? Oh, of course, I didn't code. So I think even I am idiot. I think if they are all equal is fine, right? Let's try. Okay, I think I probably have to come back again to get more familiar with the this recursive code. I don't know why I put the while loop in here. Um, yeah, because if we put the while loop in here, we we would call it so many times. It's like while loop and the recursive call. So just use the if function. So the base case and the recursive call. All right. So um, next one is the daily temperature. So I think this one is extremely, it's not so easy. Um, so it gives you the temperature array, and you should return by how many days we would see a greater temperature. So for this example, like 1, we will see a greater 74 is larger than 73 after 1 day, 75 is larger than 74 after 1 day, and the 75 we would have to wait 4 days to see the 76. So so to approach this question, we might use to have we might need to use a stack that is basically when we traverse the every element in the temperature. If we saw this temperature, the current temperature at index I um, is greater than the value of in the stack, then we perform like a while loop. We keep popping off from the stack, and we update the index. So so yeah, so we would have a stack that is storage like index and value, and then we would have a result that is we just initialize by the length of temperatures. Okay, and we just have to iterate through them. Numer numerate temperatures, right? And as long as we have stack and the current value is greater than the stack of the very last one, and the value, because we want to get this one, we want to compare what's the maximum of it. So if we found if it's larger, then we just keep popping it and we update our result. So the stack um, t value, um, we have stack index and stack value dot up, and then we would update our results. So the results, I is will becomes um, the um, so yeah. So we would update the result, and if it's not happening, means like the current temperature is less than the last element in the stack. So in that case, we just append it to the stack, because which means we haven't found the greater temperature so far. So we can just stack the append, um, and we can just return the results. Did I did something wrong again? Oh, I think it's less then. So yeah, right. Or no, it's greater. But why? Where did I do wrong? Oh, so we have to update the state index. So yeah, yeah, because we pop it means like this is the one that we are going to update. So I think for example, right, and we might have a stack is like so for so initialize we would have a bunch of zeros, right? Okay, so something like this. And so for the 73, so since right now the stack is empty, so we update our stack with like 0, 73, you know, and then it comes from 74, and is 74 larger than 73? Yes, it is. So we pop this from the stack, and so right now the stack, oh no, the stack is empty. So initialize we only have like 0, 73 in the stack, and the result is a bunch of zeros so far. So so we'll pop this since we saw the 74, right? And 74, and then we would update the 74's index means is in here, and the 1 minus 0 is 1, so we would update here, and we continue. Um, so so right now we append our 74 into the stack as well. So should be 174, and now we go to 75, and it's the same process. We go like 1, and now it's like 275, then 71 again. So since it's not like the 71 is not larger than 75, so we keep appended. So it's like 0, 1, 2, 3, so it's like 3, 71, and we go to 69, so it's also like 469, and then we reach the 72. Is it larger than 63? Yes, it is. So we update our fourth um, the fourth element. So right now it's like still like 0, 0, and 0, but now it's like um, 4. So the current index is 5. 5 minus 1 is um, like 0, 1, 2, 3, 4, 5. So 5 minus 4 is 1, and we should update the 0, 1, 2, 0, 1, 2, 3, 4, something, right? So it's 0, 1, 2, 3, 4, and we pop this off, and then now we have like 572. So after we finish all this, we should update, we should keep popping off this list. Then we would update all this. So so yeah, so so the 75 will be updated, but it's like we have to wait until 76. But you get the idea. So that's for this question. And for the time complexity is big of n, since we are just doing one scan. And also memory complexity is big of n because we have to use a stack. Okay, and for the I'm not sure if I mentioned the time and space complexity for this one. I don't know. I think it's already optimal enough. Like it's basically just keep calling itself to generate all the parentheses. So big of n. I don't think this question is like how to explain it in the big of n. um, Maybe 2 to the power of n, because you know every node you have two options. So yeah, so I guess that's the that's the time and memory complexity. And this one is more like data structure design questions. So it's pretty efficient. It's basically the stack. Um, yeah, just keep append and plus and divide it. So we go n, I guess. And this one is also like a design question. But here we are using the built-in function, so it's kind of lazy. But that's the beauty of Python. And last one is the car fleet. This one is pretty hard. So basically, it's like we have to sort we have to first we have to pair the speed and position into a list. Then we sort them by the position, and then we reverse it. So so the way we are doing it, because then we are going to iterate through every pair, and if the time who so from so we will also have like a time if it's greater than the previous time, means that it will arrive um, if the time needs for the car close to the target is less, um, then the next one means it will goes to the finish line first without attaching to others. So it's not like the same fleet, and so it can be count. We can increment the count by one. So so this question is, I think I probably need to memorize it because I think right now I can barely finish it. For P and S in the position and speed. Okay, then we have to sort them. So sorted pair, and then we have to reverse it, right? So then we can have a previous t is equal to none, and how many counts we have. Okay, so for I in for position and speed in as pair, um, so we need to calculate the time. So the distance is target minus position, and the time required is just distance divided by the speed. But be careful. So here you have to use the float. So it has the correct calculation. Um, and all right, here's the juicy part, right? So if um, free t and so okay, so if not pre t means if it's not the first time, if it's the first time, or um, or the t is larger than previous time frame, we just break t is equals to t. We update this by this one. We just calculate it, and we also increment by one. Yeah, because if the current time takes longer than the previous time, means like it will arrive the target. It needs more time to arrive the target. So which means they won't collide with each other. So for every car we just do it, we will know if this car will catch up the next car, and we just count how many cars will basically just count how many cars will hit will not hit others, so that we know how many car fleet we have. So after all that, we can just return the count. Okay, so made it. Okay, so for the time capacity for this one, since we're sorting them, and so it's big O of n log n, um, and then we also like iterate the 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 pair again, so it's also big of n. So so yeah, so the time capacity is big O n log n in this case. I think n log n is larger than n, right? Is larger than n. Yeah, because okay, so log n is greater than 1. Yeah, something like this. and log n constant and log n square to the power of n. Okay, so I guess that's today's streaming. All right. So far I don't have any. haven't. I do have a few phone interviews coming. But right now I think I'm still having a hard time to. I've been applying maybe like 60 to 100 companies every day. Um, I think I might keep just brushing my resume, and also I think today is a happy birthday to my best friend. Um, so hope she had a wonderful day. All right, that's it for today, guys. Hope you. I don't think you will enjoy it. If it were me, I probably would close the video. Anyways, it's just my daily vlog. God knows, like maybe this video may be seen by so embarrassing. I don't know why I'm doing this, to be honest, but just want to show like life is a struggle is real, but just keep pushing. All right, peace, guys.